Okay, so I'll be talking today about Kubernetes, the Docker orchestration or container orchestration. My pure experience with that technology is well, by working in Flyer. We're doing big data and machine learning applications, mostly now focus on revenue management. So, couple of questions in the beginning. Who is using Docker Compose or Docker in their daily workflow? Okay, that's great. Did anyone use in the past Kubernetes? Okay, that's perfect. I could, how to make it full screen? Okay, how I can make it? Okay, so what I want to do is actually show you some of the basic concept in Kubernetes. I won't go too much in deep, as this is not DevOps meeting, so hopefully you will forgive me for that. But I will try to nail only the most important things that are in Kubernetes. So I start my talk by naming it "Let's deploy an application." The biggest problem for me when I started to thinking this morning what I will present is I don't have an application. So I developed a small application based on 3 microservices, and mostly my talk will show how this works. Okay, so Kubernetes. It's a project owned by Google. They are mostly governing this part, and I think they deliver best service in the Kubernetes orchestration and auto-scaling solutions in Google Cloud. I definitely recommend everyone to check it out, their service. And that's it. Pods. So Kubernetes is actually operating on different kind of objects, and most primitive object in Kubernetes is pod. Pod is ephemeral. By saying that is that pod can fail, can be evicted, can happen, whatever. There are a lot of lifecycle states that can happen to the pods, but you mostly will not run a pod by yourself. You will use other kind of objects that will actually manage the pods. So pod can be structured from 1 or more containers. In some cases, you won't have, for example, 2 containers in one pod. For example, one will be writing to file, and second will be just reading from it, and they will have the same storage. But in 99% cases that we mostly have 1 container per 1 pod. That helps a lot of scaling. Pod has some resources allocated to itself, like CPU. So you can say, for example, that you want to give from that 1 pod 10% of CPU that is available on the node. Or you can assign some memory. So you can give soft limits and hard limits, how much memory can be consumed by that pod. So in other words, the pod is a single instance of an application. So it's just deployed container. So when you do spinning Docker run it's basically what is a pod. Pod also has some networking that is assigned to it, that is internal, and without forwarding, you will not have access to any of the pods internal. The second one is Replica Set in deployment, and those 2 objects mostly is used in conjunction, especially the deployment is actually owning the Replica Set, and because of that I merged in one slide that. So Replica Set is some kind of controller or manager of the pods. So we have, for example, application like API. It doesn't matter for the front end how much pods you have of that application because it talks to one database, right? So the outcome of requests coming to any of those pods will be the same. So you can really easily scale with Replica Set and say that Replica Set have to manage 5 pods with, for example, 200 megabytes of memory for each pod. And you can set some anti-affinity and affinity rules that will say that, for example, if you have pool of 10 servers in the cluster, 10 nodes, that, for example, that node cannot be on the same server. They should be on the different servers. So you can set some affinity or anti-affinity rules if you want. Deployment is actually control of Replica Set. So deployment helps you to do updates to the Replica Set. Replica Set by itself can be removed and recreated. And deployment is actually doing patching of that Replica Set. So for example, you had 10 pods, 10 replicas of pods in Replica Set, and you're changing that in deployment object to 1. And deployment is actually updating Replica Set, killing those pods, and after killing those pods, it will just maintain that one pod is always available to Replica Set. Pods are born and killed by Replica Sets, and they are never resurrected. It's of a thermal object, as we said before. So here is an example of actual deployment object that has replicas. So you can see here that you have 2 replicas. They have some selectors for the pods that can be used later also for building services. You can see here, of course, the requested CPU and memory. So for example, we use like 4% of CPU and about 50 megabytes of memory. So it's not a lot. It's actually quite a lot, but not a lot in terms of what we have right now. You can also have some readiness and liveness probe, which will ask, for example, for API or for socket, is that pod ready? So whenever it's stated that it's not, you'll see that pod is spinning. And after, for example, I have failure threshold for 2. After 2 fails, it will manage that the pod is failing actually and can remove it and respin it again. Service. Service is an object that can help you group pods. So Replica Set is managing and controlling the pods, and sometimes you want to group that pods in one group and you want one interface to all of those pods. That will do networking. So this is done by a label selector. As you could see here, to every template of the pod of the Replica Set, you can set up some metadata. And that metadata will be used later for selecting those pods in service. So as an example, you have label name orchestrator Ruby. And whenever I do service that will have selector name orchestrator Ruby, all the pods, regardless from which replica set, if for example you have 5 replica sets with 5, 4, and 10 pods, they all will be grouped in one service. So you can do selection of those pods through labels. Okay, so that was service. Config map and secrets. That's kind of a very neat part of Kubernetes. So you can store all the information for environment variables in cluster, and you can have config maps. In config maps, you store plain data that is needed for the application in name variables. So for example, I don't know, URL to other service. In secrets, you have base 64 encoded secrets like passwords, credentials, API keys, etc. So for example, here we have object of config map, and this config map is for API config map. The namespace is staging. I will talk about namespaces later. And you have one environment variable which is Redis URL. And it's pointing to Redis staging master. Okay, so those objects here that I show is mostly what you need to know on the developer level how Kubernetes works. You can learn also about stateful sets, non-stateful sets, and a bunch of other things that are available in Kubernetes. There is a lot of those. But these ones can help you bring your app to working. Okay, so Helm. Helm is one project that is also actually was governed by Kubernetes project, now is outside of it. What's package manager for Kubernetes. So for example, if you have any databases like Redis, Postgres, Elasticsearch, you can have a chart that is describing how to deploy container with that database to have fully working service without any configuration. And also help with upgrades and those stuff. Unfortunately, don't use it in production if you don't want to run into problems. There's a lot of issues with even stable charts that are actually in charts repository. We use those, and we definitely say use any managed database service that is available on your cloud. Don't use those in Helm. But if you want something for development only, non-production, then Helm is perfect because you don't have to pay additional cost. You can deploy this into your cluster. So you want for Postgres, for example, in your cluster, just use cluster with the Postgres, and that's it. Okay. So there'll be some live demo. I thought that would be a good idea to build an app to show how to deploy to Kubernetes. And I thought that Kubernetes is best for microservice architecture. So I thought I will write free applications, free services. So it will be, I use today Ruby after 5 years. I use Python and I use Node.js. And they will have different roles, those services. So here is a very simple diagram. I have orchestrator that is written in Sinatra in Ruby. I use Python for API. I use Redis for sending the tasks, and Node.js for consuming those tasks and saving the results into the Redis. Orchestrator has also API endpoints that can enable you to read those results. So app is nothing fancy, but actually what it's doing is I have an endpoint called Am I Famous? So what it's doing is actually sending REST call to Python. This is publishing the task to Node.js, and Node.js is asking Wikipedia your name in a search. Is it available in Wikipedia? And results from Wikipedia are saved into Redis, and those results from Redis are read through API. Does that make sense? Do you have any questions? Okay. So basically, just very simple endpoints. I don't want to build any open API or anything because I didn't have time, but we have health check endpoint. That health check endpoint is used by Kubernetes to make sure that the pod is working. If he's receiving something non-200, then it will be worried that the pod is dead and he can eventually remove it. We have Am I Famous GET request. And what is actually very funny is that the orchestrator is receiving GET request, and the reason is that I want to be able to cache that request. But actually what is happening is Am I Famous from the Sinatra is making a request to Python application to the job endpoint, and that job endpoint is actually receiving post request. Okay, and we have result. The result is to just read if there is anything from Wikipedia saved to Redis, and delete if you want to delete that from the Redis. And all the endpoints from Ruby, the orchestrator, are actually calling the Python application class. And the Node.js application is doing only requests to Wikipedia by taking another task that are available in the publish subscribe queue. I use, what happened? Okay, sorry. I use Sinatra, Flask, and Commander, so you have plenty of possibilities to mock my coding skills in different languages. The all code for this presentation is available in GitHub. If anyone to open, just feel free to open. I can publish this somewhere. It's fully available for you. So let's do it. So first, I will just show you OLE2 application. So let's start with Ruby. This is very simple Ruby. Sorry about that. I'm reading one end variable, which is API URL. I'm building xcon is actually a request library that you can do HTTP requests. And I define different endpoints like health check, I'm famous. And here I'm doing requests to Python application. Okay? So this is Ruby application. We have Python application. This is simple Flask application. Here I'm reading Redis URL. And I have some Redis application, and here are the views like health check view, job search view, result view, etc. And you can find the results. So nothing fancy as right? Okay. And I have Node.js application. It's also reading Redis URL from environment variables. And we have here subscribe client and normal client. Subscribe is listening to the jobs queue to actually channel, to jobs channel. And whenever it's receiving the message, it's reading the message and asking Wikipedia about search request. And that search request response is saved to the Redis. So we have 3 different applications in 3 different languages. And that's the beauty of Kubernetes, that you can use whatever you want with Docker containers. You can use whatever language you want. And if you feel that this language is better for this task, you can use it. Okay, so normally we use something like Docker Compose. And here we have 3 different services. We have orchestrator service, that is the application in Ruby. It has environment variable web API. It has one port that is actually shown to the front facing. You have web API, worker, and the Redis, right? I really love TDD. Who loves TDD? Perfect. TDD is great. Unfortunately, I don't know all the languages and their tools for unit testing, so I didn't write a unit test, but I told myself that I will write some Postman tests to the API to just making check that all the API is working for me correctly. Okay, so we can do Docker Compose up. And we can try if the application is working correctly. So first, health check. It's working, it's okay. Here is a function for I'm famous. It's small screen, 1 sec. The tests, all the tests passed. Test results 3 on 3. The test passed it. We see that we have some job ID and the search was Albert. We ask for the results. How to, sorry, oh, here it is. So we have results from the Wikipedia here, and we can delete those results and have some negative testing. If I remove something, I should have 404 when I do the same request for delete, and it's also passing, it's 404. So application is working. So this is application working. You understand? Yeah, application is production ready. That's great. Sorry. Again, very sorry. This was using Docker Compose, and I can kill that. Make sure that, okay, there are some, okay. And now let's get to the Kubernetes. So okay, so I have different types of objects in my Kubernetes. Config map, so for example, API application needs Redis URL, orchestrator needs API URL, worker needs Redis URL, etc., etc. You can see the namespaces. And namespaces can help you separate the different applications by namespace. So for example, you want to have the same whole environment, you just create new namespace and you deploy the same set of objects for just different environment. So for example, here we have dev environment. So what I will do, I pre-prepared a makefile that can help me create dev, staging, etc. What is also, I think, beneficial here is that deployments objects, let's take one. As we told before, it has metadata, etc. Has also everything hooked up from here. So you have, for example, environment variables from config map. You have networking defined by the port, right? So you have port name HTTP, and if you can see the service is referring to that target port with HTTP. So I'm selecting orchestrator Ruby, and the role is orchestrator, and based on that, it's targeting my orchestrator pods that will be spin off. Here is also replicas, so we have two replicas of orchestrator, and later I will show you that there are actually two. So to make sure that I'm not doing dashboard, I'm not doing anything fancy. Here is the dashboard of Kubernetes, and as you can see right now, there is no namespaces beside default, kube public, and kube system. Right? There's nothing here, so there is not. It's just very pure new instance of Kubernetes that I deployed locally. Okay, sorry. I think this is in cable. Okay. So what I will do right now is I will do make create dev. Oh, I didn't do one thing. To have Helm, I just need to do Helm init. And I need to wait that in kube system, there is a tiller pod deployed. Okay, now it is. So if I do Helm ls, I have no applications. Okay, make create dev. Okay. It's same. Yeah, it's the same. Nothing. Remove or delete. I don't remember. Delete name space dev. Okay, I will just modify this makefile for this demo because I did one mistake. Sorry about that. Okay, everything is spin off. And if we do kubectl get pods namespace dev, we can see that there are containers that are running, that are creating. They're not definitely ready right now, but they're just spinning off. So after some time, you can see that ready is 1 1, 0, etc. We can also just do deployment. Now you can see that we have some of the desired state, the current state, and up to date, and how much is available, and the age of those deployments object. So if you see here, if we go, I will refresh. We have now dev environment. There is one container failing for some reason. I will see why. I made it a boo-boo. Sounds it should be there. So let's do replica sets. Okay, it was first time when he hit Redis, the Redis wasn't available, and after some time that Redis just came up. Okay, perfect. So he was just joking with me for a second. Sometimes you need to wait that everything will fall in place because I didn't do nothing. Okay, so I have still my Postman collection. I changed my environment to the dev environment. Nothing fancy here. We can see that this is some API base, which is different URL and some job ID. And if I do run the tests, the test should pass at some point. Okay, this test didn't pass, but at some point it will pass because the results were sent after the request was made. But you can see that all the tests are passing. The service is actually working, and all these services were responding correctly, which is worker did his job, API did the job, and orchestrator did the job. Okay. I'm not sure if you want to see building another environment. It will be quite the same like with dev. So I'll create just new environment, and that will be separated from this first one to making sure that I'm not making this up. If we do request like that, and we do health check, this is a real working application. Okay, so this is dev, and I will just do create staging. And staging, oh, HTTP, okay, stage it. It's temporarily unavailable because pod is not ready. But to not make it longer, cube dashboard. We can see that we have new environment here, which is staging, and in staging we can see all the replica sets with worker, API orchestrator, and different Redis instance. And this is actually the same code. I use the same code. I just spin up new environment, and that's it. For more, you can go to my GitHub where I push everything, and it's available. You can just like analyze that in your free time, and that's basically it. Why is my presentation? No, not this one. How to So, any questions? Okay, that's really good question. So one is that you can use the dashboard as I show you here. So as you see here, I just go here and I have my logs. But of course, everyone loves shell, right? So let's do shell. We can do logs minus L name, and name was orchestrator Ruby. Oh, Ruby. Oh my god. There is no logs for it actually. Oh, there is no logs because it's not that environment. So you can see that here is the all health check stuff and some of my requests, right? And I can also look on the staging. On staging there is also, but I didn't do any requests on staging, so it's empty. Of course, if I want to do like, I don't know, API Python application, I use those selectors always. So all these selectors that I show you in the replica sets that are for the pods, it's kind of important to do good labeling of those pods and different Kubernetes objects, because later you can use the selectors to find them and do filtering, because those logs aren't from one pod, they're from all the pods that are matching that pattern. So if I have Ruby and Python applications on one label, it will filter out logs from both of them, and they can be more fancy here, if I tell. Does that answer your question? Okay, perfect. Any more questions? So yes and no. So for local, we use Docker Compose, but for deployments, for dev and staging, we use Kubernetes, and we use it for production. We don't use databases in production Kubernetes, we use managed services. But what is kind of nice that you can have, we for example have a Slack bot that can tell, please deploy me feature branch, which is the build image that passes all the tests on that environment. And if we have 10 or 20 microservices, we just say which service and which branch, and it's deploying automatically on that dev namespace environment. For staging, we, for example, have CI/CD pipeline that automatically build the image, do the tests. After test is deploying, is doing behavioral tests. As we have a lot of microservices, important to have some smoke tests also. So we have also smoke tests beside that, and image is automatically deployed whenever we change. So we just change the labeling of that image and deploy new image. And this is done automatically by CI/CD pipeline. So mostly developers don't even know that in our company. They use just Docker Compose, but we're thinking that sometimes awareness is a good thing, so we just try to learn people how to use it, especially for dev, because on dev many things can fail. Can I compare what? Yeah. So Docker Swarm has kind of little different philosophy. Kubernetes is Kubernetes is fully working on the premise that it has one master node and has different lot of so-called child nodes or nodes that are just deploying application. Master node, you can have multiple also master nodes, but mostly you have one, and you can have like 20 nodes that have different sets of applications, right? The Docker Swarm works a little differently in terms of that, and we tried once it, and it was having a lot of issues at that time. I know there is now Docker stacks that you can deploy automatically, fully bundle applications from different images, and just deploy that on Docker Swarm. But I never tried, so I can compare to that, because that's kind of experimental stuff, but it's kind of neat also. Any more questions? Okay, thank you very much.